All right, this is part 2 of our lesson reviewing the polynomials unit. With this video, we're going to pick up with even, odd, or neither, and a little bit of end behavior. Okay, so you have to be prepared to prove that it's even, odd, or neither. Now, you should be able to know at a glance. So just in case I let you get away with just telling me from a glance whether it's even, odd, or neither, how should you know just by looking at the equation if it's even, odd, or neither? Start with you. Something about the exponents. Tell me more.
If they're even or odd.
Okay. So what if there's a mixture? All right. So if all of the exponents are odd, including the invisible ones, then it will be odd. If all the exponents are even, then it'll be even. If there's a mixture, then it'll be neither. Okay? Now, when I look at this, I only see one exponent. It's a 3. So why didn't everybody say odd then? Why did you guys say neither?
X is.
What's the exponent of the x?
1.
That's 1. Okay, still odd. So what's the problem?
0 is even.
Oh, when you have a constant, that's always like having x to the 0 power. And 0 is an even number. So we have 2 odds and then an even. So that's why it's going to be neither. So we know that it's going to be neither because of that. And did they say that we had to prove it? They just said determine. They did say show work. Okay, so that means we have to do it the long way.
Oh, that's right.
So we already know the answer is going to be neither, but here's how you show your work properly. The first thing you do is, up above here, probably, go ahead and create the function that is negative f of x. In other words, just multiply everything by negative 1. So that'll be negative 2x to the third power, positive 3x minus 1. Okay? And then, for the sake of completeness, you should also create the function f of negative x. All right? That's the function that you get if you plug in negative x where all the x's go. Okay? Now, when you do an odd power to a negative number, the negative stays around. So this is going to become negative 2x to the third power. Negative times negative is a positive, so this will be positive 3x. And then the plus 1 just stays plus 1. Okay, so I'm going to put a box around this. Okay, f of negative x. And I'm going to put a box around this. Okay, so here's how you judge whether it is even, odd, or neither. Look at the blue function that we just found, the f of negative x. If the blue function matches the original function, all right, then it would be even. On the other hand, if the blue, oh, by the way, does it match? No. Positive 2, negative 3, positive 3, so that does not match. If the blue function matches the opposite function, all right, this pink one, all right, if those match, then it will be odd. So negative 2x to the third power, negative 2x to the third power. Positive 3x, positive 3x. Looking good. But then, negative 1, positive 1. So close, but they don't actually match. All right, so it's not odd either. So if it's neither even nor odd, then we just put neither. And that's how you prove it. All right, and that's how we would have to show our work. Okay, now, end behavior. Here's where we really got torn apart. It's all about knowing what the function basically looks like ahead of time. I feel like I need to go to the other screen for a second. Okay, we learned a long time ago, if we have a function that is odd degree, like f of x equals x to the third power. What's the general shape of cubic functions? It's like an N shape, sort of like a capital N is the general shape. Okay? And this is the positive version. All right? Put a little plus sign here. So, as far as end behavior, all odd functions have the same end behavior. So, if it was x to the fifth power or x to the seventh power, etc., it would actually have more bends in it, but the end behavior would still be the same. Fernando, strike one. Keep your eyes open.
Arrows.
Yeah, no. The negative version would be like upside down n. Okay, so this would be the negative version. How do even functions look? So say if I have f of x equals x squared. What kind of shape do these things make? Yeah, like a parabola. All right, and this would be the positive version, and this would be the negative version. Okay, now if I had something like x to the fourth power, it doesn't make a parabola. It has an extra bend in it. But the end behavior is the same as a parabola. Okay, both arms reaching to the sky. So all even functions have the same end behavior. All odd functions have the same end behavior. Okay? So, now looking back.
Wait, did you do neither?
So this function is, what's the degree of this function? All right? It's hard to see. I got to erase part of it. See, it's x to the third power. So that means we're dealing with an odd shape. Is this going to be a right side up n or an upside down n shape?
Right side up.
It should be like right side up. Okay, do this purple. So we should be picturing this in the back of our minds. All right, it's a positive leading coefficient, and it's like an N shape. So when you do the end behavior, look at this. On the left side, see how it's heading downward on the left side? So that's why that should be, wait, it's backwards. I usually put the left one first, but whoever created this document put the right one first, okay? So this one here at the bottom is actually the one as we go to the left, okay? So as we go to the left, we're going towards negative infinity. As we go towards positive infinity, that's the right-hand side, so it's going towards positive infinity. So this is what everyone should have for number 11. Okay? All right, so looking at number 12. Okay, so we have the original function, but we need the opposite function as well. So here's the opposite function. Would be positive x to the fourth power minus 2x squared minus 1. Okay, now we need f of negative x. So that would be like this. Oh, let me actually do it. When you raise a negative to an even power, the negative goes away. So this will just be negative x to the fourth power. This negative goes away, so it'll just be 2x squared. And then I've got the plus 1. Okay, so here's my... Because we're squaring it. Okay? So, when you do f of negative x, if it matches the original function, then it's even. Okay? And it does match the original function. So that makes it even. All right. Also, you could look at a glance and see that all of the powers are even. If you count the fact that we have 1 is like 1x to the 0 power, and that's even. So they're all even. It's another way to look at it. Now, as far as end behavior, you see that this is an even degree function. The degree is 4. So that lets us know we should be picturing some type of a parabola-like shape. Okay? So it's just a matter of, is it going to be an upward facing, W? Or should it be more like an M? All right, so which shape should we be looking at now? Because of the negative leading coefficient, we know it's going to be the downward facing end behavior. So that's negative infinity on the right and the left. All right, any questions about number 12? All right, for number 13. All right, we've got the original function right there. Here comes the negative function. Negative 2x to the 5th power minus 3x to the 3rd power plus x.
So this is showing the work, that's how it's showing it?
Yeah, this is how you have to show your work.
Alright, I know that.
Okay? And then we do the f of negative x. Okay, if there's an odd power, the negative is going to stay around. So this will become negative 2x to the 5th power. And this will become negative 3x to the 3rd power. And a negative negative is a positive, so this will be a positive x. So here we have f of negative x. Now I compare this back to the original function and the opposite function. It obviously is not the original function, so that means it's not even. Does it match the opposite function though?
Yeah.
It does. So because it matches the opposite function, it is odd. And that's how you show your work. Got to show your work.
The opposite function is negative f of x, right?
The pink one is the opposite function.
So you put
Okay.
negative 5x and
Exactly.
then the negative x.
That's where you plug it in. All right. Now, this is an odd degree function. You see the 5? So that tells us in terms of end behavior, we should be using one of our end shapes to guide us. Okay? Just as far as end behavior. Now, a true 5th power graph has extra bends in it. Okay? Like it would be more like this. But it doesn't matter. Just look at the end behavior. Fernando, strike 2. Keep your eyes open. All right? So it's just a matter of whether it's a right side up N or more of an upside down N. Because it is a positive leading coefficient, we should be looking at the right side up N shape for the end behavior. So on the left, it goes down. So that means as x approaches negative infinity, negative infinity. On the right, it goes up. So as we go to positive infinity, positive infinity. So that should have been our end behavior. Any questions on number 13? Okay, one more, number 14. All right, that's the original function. Now we'll do negative f of x. So that would be negative 5x squared minus x. And now we'll do f of negative x. When you have an even power, the negative goes away. So this will be 5x squared, and then just minus x. All right, so what do you think? Is this even, odd, or neither? This is neither. All right, it doesn't match the original function, and it doesn't match the opposite function either. So this is neither. Okay, now end behavior. You see that this is degree 2. So you should be picturing a parabola shape. And because it's a leading coefficient positive, it should be an upward facing parabola shape. Vicente, please uncover your eyes. So it's positive on the left, positive on the right. Strike 1. All right, any questions on number 14? All right, for number 15 and 16, we're supposed to just look at the graph and tell if it's even, odd, or neither. What do you think about number 15? What do you say?
Odd.
Yeah, number 15 is definitely even. It's going to be even if it has y-axis symmetry. If the y-axis splits it right down the middle and it's mirror images on the left and right, then it's even. Y-axis symmetry.
Neither.
Okay? Number 16 is going to be neither. Okay? To be odd, it has to be symmetric, rotational symmetry around the origin. This has rotational symmetry, but the center of rotation is way up here somewhere. If that point were at 0, 0, it would have been odd. Okay? Yeah, to where if you turn it upside down, it would look identical. Right, if the origin is the center of rotation. Okay? For number 17.
Odd.
Number 17 is going to be odd. Because the origin is the center of rotation. If I take this and turn it upside down, even when we turned it upside down, it still looks identical. So that's why this is odd. Alright, and that's enough for one video. So I'm going to end this video here. That'll be the end of part 2. We'll pick up with part 3 with problems like this where we're having to find the zeros and do synthetic division and use our TI-30XS multiview, all that good stuff. Alright, I'll see you on the next video.